Calculus Made Simple and Interesting by Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are taking another very beautiful question based on related rates of change. We'll find the change of the shadow length. The question here is, a ball is dropped from a point 12 feet above the ground so that it will land 4 feet from the base of a 12-foot lamppost. At what rate is the shadow of the ball moving along the ground when the ball is 8 feet above the ground? So this is an application question for which first you need to write down the equation and then solve it. Well, in case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. Now, let's look into this situation and understand first, and then we'll get into its solution. So let's say that's the ground and a ball is being dropped along this line and it falls 4 feet from the base of 12 feet lamppost. So let the lamppost be right there. Okay. So it falls 4 feet. So that is 4 feet. Now, as the ball falls, there will be a shadow on the ground. Let us represent this shadow. Where, let's say this is the light on the top of the lamppost, and at any given instance of time, let me draw a better line here. The situation will be kind of like this. If the ball is at height of y, for example, in that case, shadow length will be x. Right? So that becomes the shadow length. We are interested in finding the rate of change of shadow length as the ball is falling. Right? So you see the length is decreasing most of the time, so you expect a negative answer. Perfect. We are also given that this lamppost is 12 feet high. And ball is also dropped from the same height, correct? So how do we relate x with the height y? That is what you need to figure out. So in physics we have learned that the height can be written as initial height 12, right, in this case. Let me write h0, give you a formula first. Now since it's falling, so it is decreasing at the rate of half gt square, where of course t is greater than equal to 0 and g, since we are talking about feet, is 32 feet per second square. Make clear? So that is what your basic equation is. In our case, we are considering height at any instance of time as y. So I could write this as y equals to, and initial height is 12 minus half 32 for gravity, acceleration t square, correct? So you can write down the equation simplified form as 12 minus half of 32 being 16 t square. So that becomes the change of height with time, right? Now, what we are given here is that at what rate is the shadow of the ball moving along the ground when the ball is 8 feet above the ground. So when the ball is, let us say, 8 feet above the ground, let's say this height is 8. So at this instance, we need to figure out the rate of change, right? Okay, so let's find the instance time, right? So if I put 8 as the height, I get 12 minus 16 t square. 16 t square equals to 12 minus 8, which is 4. And now we can solve for t, which is t square equals to 4 over 16, which is 1 over 4. So t will be equal to square root of 1 over 4, which is half second, right? So after half second, the height of the ball is going to be 8 feet. Is that clear to you, right? So we got the time now. So we know at t equals to 0.5 or half seconds at this time. Perfect. So lot more things to be done. Now we need to find what is dx dt when t is equal to half second. Is that clear to you? This is what we need to figure out. So I hope this situation is absolutely clear, right? So we'll move forward and then solve it, relating x and y to find dx dt. Meanwhile, let me thank all the subscribers and viewers who have been watching my videos, posting excellent comments and suggestions. Special thanks to those who are providing us with some contributions to sustain growth. We had been serving you for last 15 years absolutely free with 17,000 videos now, which are being watched over 80 countries. Most important thing is the quality which we provide. Access to this quality in remote areas is something which we want, that's our passion, and your support can help us reach millions globally. So keep supporting. Thank you. So let's get back to the solution. So we figured out that in this situation, time will be half second when the ball will be 8 feet above the ground. So on the next page, let us now see how do we further solve. So let me repeat here, sketch the diagram which we just made, and as you can see, the focus now is to relate x and y being the height and x being the length of the shadow, where the ball is falling 4 feet from the post, which is 12 feet high. Correct. So we can now relate. If you see a small triangle and the big triangle, which is similar triangles, right? So this small triangle is similar to the big triangle. In the big triangle, height is 12 and the point base is 4 plus x. Correct. So from similar triangles, we can relate this to x over y is equal to 4 plus x over 12. Make sense? So that becomes the relation, and we can relate x and y. We've already figured out that y is equal to, in the last page, y is equal to 12 minus 16t square, right? We also found that at when y equals to 8, t equals to half seconds. Okay, great. So we have all this. Now let's isolate x, right? So what we are going to do is take y on the other side, or we can just cross multiply first. So let's do this part. So we get 12x equals to 4y plus xy. So I just cross multiply. Now bringing x together, isolate x by taking it as a common factor. So x is equal to 4y over 12 minus y. Clear? So we have an equation where x is 4y over 12 minus y. Clear? Now let's find the rate of change. So dx dt is equal to, apply the quotient rule. So derivative of 4y will be 4 times y prime minus derivative times, times 12 minus y, quotient rule, right? Minus derivative of denominator, which is minus 1 times 4y and minus 1 y prime, right? Divided by. We are differentiating with respect to time t, okay? So this is when we differentiate with respect to time t. So that's what we get. We can now simplify this a bit. Y prime, as you can see, is common, right? So we'll take y prime here. And 4 times 12 minus, so we'll open the bracket. 4 times 12 is 48 minus 4y. And this is plus 4y over 12 minus y whole square. Clear? Now we need to find what is y prime, right? Okay, let me simplify it further. So we have, let me change the ink code. So y prime times (48) because minus 4y and plus 4y will cancel. So y prime times 48 over 12 minus y whole square. Correct. So we have got the expression for the derivative, correct? Which is dx dt. You need to find what is y prime at t equals to half second when y equals to 8. So we know all of the values. X is given to you as 4, right? So the only thing which you want to find is y prime. So let's take it on a new page. We'll just figure this out. So dx dt is equal to, we have 48 y prime over y minus 12 minus y whole square. Okay, so we also found that the equation for the height y was 12 minus half gt square, so was 16 t square. So from here we can find the derivative dy dt will be minus 32 t, right? Now since we know t equals to half, so we can say dy dt for t equals to half is when minus 32 times half, which is equal to minus 16. So we have y prime now, correct? So we can say that dx dt equals to 48 times minus 16, right? And this is when t is equal to half, when the height is 8, right? And we have 12 minus 8 whole square, correct? So 12 minus 8 whole square is 16. So we have 48 times minus 16 over 12 minus 8, 4 square is also 16. And when you divide, what you get is minus 48 feet per second square. Is that clear to you? So that is how we are going to calculate this particular value, and that's the answer. Okay. So now let's look into the steps which we followed. We began by sketching the diagram, ball being 4 feet away from the lamppost, which is 12 feet high. So the height of the ball is given by 12 minus half, 32t squared. Simplified this to minus 16t squared. When y was 8, t was half seconds. So we have 8 and half seconds right there. And the equation is y equals to 12 minus 16t squared. Then we related the two similar triangles, x over y, with 4 plus x over 12 cross multiply and solve the equation. So 12x, bringing x together on the left hand side and taking it common, we got 4y divided by 12 minus y as x. Now differentiating with respect to time, applying the quotient rule, we get the derivative as 4 prime times 12 minus y minus derivative of denominator, which is minus 1 y prime times 4y. So we took y prime as a common factor and multiplied 4 with 12, giving 48, and minus 4y with y, added 4y, correct? 4y cancel, giving us 48y prime over 12 minus y whole square. So that was our equation. And finally, to find the y prime, we differentiated the equation 12 minus 16t squared, getting minus 32t. Substituting t as half, we got minus 16, and then placed minus 16 in our equation. 12 minus 8 is 4 in the denominator, square being 16, 16 cancel, and so we get minus 48 feet per second square as our answer. Is that clear to you? Perfect. So that is how we are going to solve this particular question, right? So the rate of change at the instance when the height, that is the y is equal to 8, at that time is half, we calculated, is negative 48 feet per second square. Means it is decreasing at that rate. Perfect. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, it'd be great. Thanks for your time and all the best.